Hi, my name is Mark Keene from Keene Engineering. We're out here doing some testing today, but originally we were out testing just the Honda engine. With all the Honda engines we sell, whether it's a 2 horsepower Honda up to a 23 horsepower Honda, we go ahead and we have to have every engine certified. So we had some certification on this engine. I don't know what happened, it lost the certification for some reason. But anyways, I'm able to sell the GX270s approved by Honda, which is nice. While I have my water tank set up and I have my pump set up and everything, I thought it'd be a good opportunity to do some more further testing on our power jets. So we were actually doing a test. I was running a 3-inch power jet with a 2.5-inch jet log with I think like a 1 1/8 inch orifice, and I was able to generate at least 15 inches of vacuum, mercury inches of vacuum. It could have been higher, but my gauge only goes up to 15 inches, so I had some limitations on my testing capability. And I figured, I ran into one of these. Eddie, if you want to show them a little closer, this is an old Gold Divers jet here. This jet was probably built back in the 70s, maybe into the late 80s, maybe even into the early 90s. I don't know the entire story of the company. I just know that the guy who built this thing was a real smart guy. I can't remember his name, but he was a real good guy. I guess my grandfather had some words and some feelings way back in the 50s, but I think he's a pretty damn good engineer. I know he built a good pump, the old Gold Divers pump, so it's a well-built jet. But I've had a lot of inquiries lately. People have been calling him up, hey, I want to build myself an infinity jet. And I go, well, you know what? I remember we used to play with them back in like when I was in my late teens in the 1980s. We were experimenting with the jets, and I wasn't that impressed then. But you know, it's been 30 years or something. So I had one here. I figured I'd go out and test it. So I tested this jet today on my test, and like I said, I was pulling 15 inches vacuum, and that's as high as my gauge would go. I tested this one, we were pulling about 7 inches vacuum, and I guess that's pretty good. But while I have it out here, I figured I'd show you guys what it looks like inside. I thought the water would spray evenly all the way around in like a cone effect. Maybe it does at the higher RPMs, but at the low RPMs where I just tested it. So I'm gonna let you guys watch this. So Eddie, can you look down the jet log for me? Down the center of the jet. I'm gonna fire this thing up. Can you see it? Okay, you got your light in there and everything? Okay, so I'm gonna fire it up. All right, so this is an infinity jet. It's not a perfect round stream of water, which I'm a little disappointed that it's not. I'm sure there's ways of making it work better. Imagine, go ahead and turn the engine up a little bit. About another quarter throttle. A little more. A little more. Keep going. Keep going. Okay, take it all the way up. Not quite a complete tone, but it's looking better. Okay, now I hope you can hear me. One thing I do notice, it does have a pretty good air vacuum here. I don't know, let me zoom out a little bit. It has a pretty good strong air vacuum, probably a little bit of priming, but we'll go ahead and test that tomorrow. I think we may have some debris inside the chamber itself. So I'm going to take this opportunity, I'm going to pull this sucker apart, A, to show you what it looks like inside, and B, to see if I can find any debris we can clear it out of there. So let's go ahead and kill the motor. Okay, so we're taking this thing apart. And like I said, I haven't been in one of these things in literally decades, so this should be interesting. All right, so I know you guys would be interested in what it looks like inside. It's a casting inside here on this last portion of it here. And we found literally just a few, I don't know if I can see this, a few grains of sand. They fell off, but just little teeny, smaller than like a small buckshot that plugged this thing up. So that was one of the big problems they had back in the old days. Let's take a look at the other side here. And then let's look in here. And you can see he just basically has the tubing here, and he machines the edge right here, and that's what creates your water line. And other than that, it looks like a pretty basic, simple system. One of the things I'm not nuts about personally, if you notice there that when the water goes in through a 2-inch port, I would actually I would personally make that chamber bigger, so you're not changing direction of the water so quickly. But anyways, you know, this is what it is, and we'll see if all this hoopla and extra expense is worth all the money. So let's, all right guys, let's bolt it back together, and now we got it cleared out. But man, that is really small stuff that created the problem. It's kind of scary. I'm surprised. Yeah. That means you'd have to keep your foot valve completely clean all the time. One gulp of sand would shut down your dredge. And also, these were notorious for getting weird wear patterns on them too. And again, I'm not bagging on anything. This is just the things I remember. So either this portion here would wear out inside, or more likely that lip right there would wear out. So you had to constantly change that. But again, I'm kind of learning. I'm not an expert on these things, but I have, you know, a lot of, I believe I do have that thing called common sense, so, and a lot of experience. All right, so let's put this thing back together, and we'll go to the next step. All right, we're putting it all back together. It took us, I hate to say, it's about a half hour to tear it apart. That's good. Yeah, you don't get it that tight. It's got an O-ring seal. But it took about a half hour to open it up, tear it apart. We had to remove the pressure hose. You know, the O-ring is a little bit of an issue. So these are some of the things you have to deal with when you're dealing with this type of a power jet. But it's all a learning curve. All right. All right. Can you drop the light a little lower? Okay, now we got, I literally only removed like 2 grains of sand and plugged it up. But it looks like we got that nice cone action going on. Now let me check one thing here. How's that? Put your hand over the back. How's the vacuum on it? It actually has a little bit air vacuum to it, huh? Yeah. Now our engine's running at a slow speed. Let's see, we're running at 1875. Let me see how this is.
Yeah, it is.
Yeah, it's got a little bit of vacuum. You know, not I can feel a little bit. Okay, so let's magic. Rev it up just a little bit for me. Take it to about 3,000. Yeah, the cone shape doesn't seem to change much. It already might have got plugged up again. You know, like I said, it takes only a grain of sand. So I don't like that about these, but it's still fun to play with. All right, that's good. Go ahead and okay, go ahead and kill the engine. All right, I'm going to show you. I'm going to actually do some vacuum tests on it now. All right, so we're going to do some vacuum tests on it. It's a pretty simple test. I have a little hose that goes against this plate here, and simply the vacuum, it measures the vacuum, and this is kind of a high-end vacuum meter. Works pretty good. I've been using that thing for a couple years now. It's always done a good job for me. So I'll do a full static vacuum test here, and this will give me a vacuum test, you know, with some flow behind it. So I guess we're ready to test it. Let's go and get the jet back in the water. Let's get the plate on one end, and we'll fire it up. About an inch of vacuum. Okay, roughly 3,000. Like we're calling this test is a little different. This is allowing some velocity to go through it. The first one was a dead static. This is just a general vacuum test. All right. Get it centered. All right. All right. Let me rev it up so it stays on there. Okay, we'll get in the water. Okay, so I went ahead and I just switched over to the standard conventional Keene jet. All right, and let's see what happens here. Let me come over here. You can see the column of water. Oh, that's a good shot. And can you come to the other side of the jet so I can get the camera in there a little bit closer? Can't quite see it. Here, let me see the light. There we go. Good shot. So you can see it now. There we go. Every time I get up to it. That kind of gives you an idea. I don't know how well you can see in the camera, but it's got a nice, clean, smooth orifice going right down the center of that sucker. Alright, so I'm going to do a quick full static test and put this one over it. Okay. I'm going to turn up a little bit so it stays on here. About the same, about an inch of vacuum. I'm kicking a fire. Rough around, I think that's about 3. Yeah, there's about 3. And we're about 5 inches of vacuum. Eddie, hold on, let's kick it all the way up now. Good? There's about 36. And we're actually pulling for vacuum about 7 or 8 inches of vacuum. Both pumps are running at the same pressure, about 33 psi. Alright guys, I hate to do this to you, but we have to go back and put the other jet back on. I was running at a lower pressure on the other jet. Oh, well, let's do this, the other static one too. Let's switch the plates before we take this one off. Put that plate on there, Eddie. So my conclusion between the two jets, the Keene jet did a little bit better job on this dead static. Now we're going to try a flow test on it to see how it works. But I'm afraid I have to go back to the Infinity Circle jet or the Gold Divers jet, whatever the hell you want to call it. And okay, go ahead and fire it up before you lose. Okay, got prime. Set. Kick it up about. There's 2. So what they're back in here? A little less. It's about. A little over 5 inches as far as I can tell, maybe 5.5. Kick it up all the way. Yeah, we're 7.5, 8 inches of vacuum. Okay, got a test done. Alright, so now we're going to switch back to the other jet. Since I was running, guys, I made a mistake. I should have checked my pressure on the Gold Divers jet. I'm going to actually take the jet. I'm going to try to adjust it, see if I can fine tune it. Now, the interesting thing, I already know this jet's dialed in for this particular pump. So that to give me a completely fair test, we're going to have to make that one change.
Okay, right there.
Okay. And what we're going to test when we get this thing running again, we're going to test for pressure. I want to bring the pressure up just a little bit from about 35 pounds to about 40 pounds. And that tells, and then from that number, I can kind of extrapolate the gallons per minute. Okay, we're going to open it up a little bit more. Just a little bit, Eddie. Okay, you saw that the thing moved?
Yeah.
Okay. All right. Get underwater. We'll test it. Our pressure range.
Oh.
Okay, take it up slowly all the way. Alright, so this next section of video is a little bit difficult to follow, so I'm going to summarize basically what we did here. The original testing pressures we were running were about 35 psi, 35 pounds per square inch. So we went ahead and we were pulling probably 7.5 inches of vacuum. That was pretty impressive. So then we went back and we closed the chamber down a little tighter to reduce the gap, which will reduce the gallons per minute, but it will increase the PSI up to about 40 pounds per square inch. And at that point, our suction had a slight drop in performance. So the trend was closing it down or getting higher pressure and lower volume was not the way to go. So then we went back to the 35 pounds per square inch, and then it seemed to have its best performance. Then we took it back to about 31 pounds per square inch, and I went ahead and tested it, and again the trend was for the performance seemed to drop at the lower pressures. Again, that was a higher volume and a lower working pressure. So all in all, you know, it seemed to be the sweet spot for that particular jet was about 35 pounds per square inch. So, and that's kind of what I typically find for a system like this. Again, I'm no expert on these you know, coupled jets, ring jets, infinity jets, whatever you want to call them, but this was a kind of a fun little test for me. I learned a lot, and I'm hoping that again you guys you'll learning along with me going through my learning curve. But it was all real interesting stuff, and I'm glad I had an opportunity to try it out. So in our conclusion, we tested both the Gold Divers infinity jet / ring jet, what I've called them for decades, and we tested the Keene power jet. And I found actually more vacuum in the standard Keene power jet than I did than the infinity jet, and I gave it a fair test because I gave it a variety of different settings. And you can't say I didn't overpower because I'm running a badass pump. This PHP 500 pump is a serious hardcore pump. We're most of the time pumping over 300 gallons a minute into those jets. We have this standard jet handy.
That one right there?
Oh, here it is. Something that people take for granted, that when you have a simple power jet system like this, the water comes in, we don't change directions. When you go into the ring jet, you come into a straight flange and you hit a wall, and the water has to spread and pressurize this water jacket here. So the efficiency of this, I believe, has greater efficiency, especially when it comes to like self-priming and issues like that. But the honest truth, that's going to be probably a half to a third of the price of what it would cost to manufacture one of these. And it's lighter, easier, and it's maintenance free. This type of jet is I can tell it'd be really good for like self-priming application. You could probably set this thing 3 feet above the water and she's going to self-prime. But the problem is there is a temperamental factor. I sucked in just like, I'd say 2 grains of like a large particle of sand, and you know what? It plugged it. So they're very temperamental. They are repairable and they are adjustable, but like I said, this is the first time I've had an opportunity to really test them head to head. And I'm kind of excited because I didn't really know the answers until now. So, but I figured I'd share this with you guys, so I get questions like this all the time. So, all in all, I choose that one. One half the weight, maybe, you know, less than half the weight, probably 1/3 the cost compared to something like this. But, I mean, this may have its place, but not really for most of the applications that I was looking at. But it was cool. It was kind of fun to try. I think you guys learned a lot too, didn't you, Eddie?
Oh yeah.
And none of us had never really played with this thing, and I had it sitting on my racks here for maybe a year or so. I was glad to have a chance to come out here and play with it. Okay, one more thing. Eddie and I were just talking, and we were talking about the pros and cons of the jet, and he brought up a very valid point that I didn't think, but now it makes sense. What were you saying, Eddie?
I was just saying that, you know, the nice part about this is that it has a good adjustment here.
Right.
You know, but you have your pros and cons. No matter what you have adjustment here, it's still going to be getting clogged for you,
Yeah.
you know, for whatever reason. Any particles, sands, rocks, or whatever goes through there is going to clog your water flow. It's not going to flow the way you want it to flow.
It's got to be a pain in the ass, guys.
Yes. Now on this one, it's the total opposite.
Yeah, you can pass rocks, sand, and almost a busted foot.
That too.
But with this one here,
You have no restrictions.
no restrictions. You can pump, you know, not that you want to pass, you know, 1/4 inch particles through the pump, but you could literally pass big rocks in the pump.
Yeah.
So it's not going to damage the power jet. But Eddie brought up another point, is that this has a little bit more adjustment. Now this is getting a little bit more on the technical side. Let's say if I had a pump, like I had a pump called the P350, which let's say is 400 gallons a minute at let's say 25 pounds pressure, and the curve is really built more for the volume side. Okay, it probably wouldn't work very well with this one. This
No.
would need a larger inside diameter. This jet here is about 1/8 inch diameter ID. It would probably require 1.5 inches to optimize the performance. Or this jet, we could possibly adjust it enough where we could hit
Get
the
that
sweet.
performance,
We could get that optimal performance, but do I know that for sure? Not really. But again, this is a great test, and I appreciate everybody's input. And hope you, like I said before, hope you guys learned as much as I did. All right, thanks.